OCR Maths and Stats Differentiation Techniques for C3 and C4. Differentiating e to the power of any function of x. So looking at the formula, we get the original function, e to the power of f of x, and we multiply that by the derivative of f of x. Starting off with an easy example, if we differentiate e to the power of x, looking at the formula, the f dash x, which means we have to differentiate f of x, which in this case is x. So if you differentiate x, you just get 1 there. So that's this part of the formula done, times e to the power of f of x. So times the original function that we started with, which is e to the x. So that just gives e to the power of x. So as you can see, the original function and its derivative are exactly the same. And this is what makes e to the power of x a special function. Differentiating e to the power of 1 plus 2x. So the 1 plus 2x is represented by the f of x in the formula. So applying the formula, the first thing we do is we differentiate f of x. So to differentiate f of x, so we're differentiating 1 plus 2x, and differentiating 1 plus 2x gives us 2. So that's this part of the formula done. And now we multiply by e to the power of f of x, so we're multiplying by the original function, which is all of this. So we have 2 times e to the power of 1 plus 2x. Differentiating e to the power of 1 minus x cubed. So the f of x this time is the 1 minus x cubed. So following the formula, f dash x, so if we differentiate the 1 minus x cubed, we get minus 3x squared, times the original function, so times all of this, so times e to the power of 1 minus x cubed, and just simplifying, we don't need the brackets there, so minus 3x squared times e to the power of 1 minus x cubed. In this example, we're differentiating with respect to t and not x, but the formula still applies. We must remember to multiply the final result by 20. So, the first part then, we need to differentiate t ln 2. And if we differentiate t times ln 2, we get ln 2. And then we multiply by the original function, which was e to the power of t in 2, and then not forgetting to multiply by the 20, like this. The brackets aren't doing anything there, so it's 20 ln 2 times e to the power of t ln 2. Differentiating this time will give us 4, that's the 4 here, times the derivative of this part, which is 2t plus 5, times the original function, So times e to the power of t squared plus 5t minus 2. Differentiating 1 over 2 e to the 5x plus 1. So rewriting this first, you can see the half there, so we've got a half e to the power of minus 5x minus 1. So we're going to differentiate. So differentiating a half times e to the power of minus 5x minus 1. So we've got the half times the derivative of the minus 5x minus 1, so that's just minus 5, times the original function there, which is e to the power of minus 5x minus 1. And we can rewrite all of this as minus 5 over 2 e to the power of 5x plus 1. Be careful with the signs here. When you take e to the power of 5x plus 1 out of the denominator here, you get minus 5x minus 1. You have to change the signs here. Differentiating e to the power of root x gives differentiating e to the power of x to the power of a half. So applying the formula, the f of x is the same as x to the power of a half. So differentiating the x to the power of a half, so a half x to the power of minus a half, that's this part of the formula done, times the original function, so times e to the power of x to the power of a half. Or we can use third form for the final answer. In this example, the bases are the same, so we can add the indices. So we're differentiating e to the power of x plus x squared, and then differentiating, starting with the x plus x squared, which is the f of x in the formula, this part here. So differentiating gives us 1 plus 2x times the original function times e to the power of x plus x squared. In this example, there is no need to use the product rule for differentiation. Okay, the product rule for differentiation, if you're already familiar with that rule, will give you this. Okay, so differentiating e to the x times e to the x squared. So you've got the function u there and the function v here. Differentiating u, so du by dx is e to the x. Differentiating function v, so dv by dx is 2x times e to the x squared. And then you're just cross multiplying to give this, and simplifying, because you're multiplying these terms here, the bases are the same, so you can add the indices, so the x squared and the x you can add, and you can do the same here with the x and the x squared there, like this, then factorizing, and you have exactly the same result as this, but with a lot more working out. Okay, so this method here is more efficient than this one.